Hey everybody, welcome to You Can Do Math. Today we are going to discover the beauty of chords in a circle. Chord, where the endpoints are on the circle. Alright guys, let's get started. Alright, so the beautiful circle that is in front of you has a chord. And let me show you where it's at. It's this line right here. This is called a chord because both of its endpoints are on the circle. Now let's also talk about the other parts of the circle that we can identify. The center of the circle and the other endpoint is going to be on the circle, so this is a radius. And we have more than one in our circle currently. This is also a radius because one endpoint is the center of the circle and the other endpoint is on the circle. Now let's take a look and see what we want to solve. We want to solve this little segment right here, which is a part of the radius. A cool thing is if you have a radius and it is intersecting a chord perpendicular at 90 degrees, that means that it cuts this chord in half beautifully. So the distance from this center to the circle is 16 on either side. All right, so if we want to solve for this little part right here, I want to use the whole radius of 18.9. And I think I'm going to draw in another radius. I'm going to draw in this little perfect radius right here. I'm going to clean that up a bit. I'm going to choose to draw a radius there. Now I know it's also 18.9 because all radii in our circle is congruent. So therefore, I see a beautiful right triangle. And if I see a right triangle, I know I can use Pythagorean theorem to find this missing side. Let's call that missing side of that triangle A. And then if I solve for A, then I can subtract the part of A from our radius of 18.9, and that will leave me with x. And that's the direction we're going to go to solve for x. All right, so let's go ahead and start off by writing our Pythagorean theorem of a squared plus b squared equals c squared. And our a squared is just going to stay the same. I just named it a for that reason. And then the other leg of that triangle is 16, so 16 squared. And it equals c squared. Remember, c is always our hypotenuse, which is our radius in this case, so it would be 18.9. All right, so now we have a squared plus 16 squared is 256 equals, now 18.9 squared is 357.21. Now if we subtract the 256 to the other side, we have a squared equals 101.21. And then the final step is to take the square root of each side. And when we do that, we have a is about 10.06. Now that we've found what a is, we can subtract the whole radius of 18.9 from 10.06 and we'll get our final answer. So our 18.9 minus 10.06 will give us a final answer of 8.84. And there's x. All right, so for example number 2, we're going to kind of do a similar thing. I want you to just identify the parts of this circle though. This is the chord right here. The chord is being intercepted here with a radius and it's at 90 degrees. And so since we have another radius here and it tells us that that radius is 21.1, we can draw in another radius and that would also be 21.1. Then if we solve for this side here, which we will call A, which we'll call A, then we can subtract A from the 21.1 and we will be able to find x. Okay, so let's start off with our Pythagorean theorem of a squared plus b squared equals c squared. Because we have a right triangle right here and we have the hypotenuse, which is c, and we have one of the legs, so we can solve for this part of this segment right here. And so I'm going to plug in what I know. My A is going to stay the same. The B is the leg, the 19.8, and C is the hypotenuse, which is 21.1. Now, don't forget those are both squared. Those values are squared. Then I'm going to subtract the 19.8 squared to the other side. And when I do that, I have A squared equals, then I have 21.1 squared minus or subtract the 19.8 squared, which gives me 53.17. And then the last step is I can simply take the square root, and that isolates A, and A is 7.29. All right, so if A is 7.29, then that means I can take the radius here from the center of the circle to the end of the circle, which that distance is 21.1, and I can subtract out the 7.29, and that will leave me with what x is. So 21.1 minus 7.29 gives us 13.81. Okay, so example number 3 is all for you to try. Here she is. I'd like you, I know I just said she. Please pause this video, try it out on your own, and when you're ready, press play. All right, let's see how you did. In the third problem for today, you didn't have to draw in another radius. It wasn't needed. So hopefully that didn't trip you up at all. And that you could just jump right to Pythagorean theorem and call that distance A. And so we have a squared plus b squared equals c squared, and a squared plus 9.9 squared equals our 12.5 squared. And then I'm going to subtract the 9.9 squared to the other side, just because that's just how I type it in my calculator. A squared equals, I'll type in 12.5 squared, subtract 9.9 squared, and that gives me 58.24. And then let's take the square root of that. And when you take the square root, then we have A is 7.63. And then we can take our whole radius of 12.5 and subtract the 7.63, and that gives us our final answer of x equals 4.868. So, I mean, you could say 4.9 for our answer. All right, I hope you guys enjoyed learning about chords today, and until next time, see you guys.